welcome to the podcast. This is Mr. White.
And Mr. Johnson.
And today we're going to talk about shadow and how it relates to you. So, Mr. Johnson, what, in your opinion, is a shadow?
Well, I think it's an area in which light is being blocked.
Ooh, an area, how about a space?
Or space.
Yeah, with no light. Now, this whole no light, that's a special kind of shadow. Do you remember which part that is? Is it the umbra or is it the penumbra?
Well, I always remember with no light, it's like underneath something, so I always think umbrella, umbra.
Ah, that's very good. So, yes, it is the umbra, is the part of the shadow where it is dark, where there's the absence of light, which means that there must be a space with a little light, or the possibility.
Mm-hmm.
And so that must be the penumbra. And we see this every day. We see shadows all the time. We just don't think about it.
Right.
Is there sunlight? Is there no light? Does this actually apply to anything that I'll ever do or think about again? And actually it will, because in May of 2014, the Midwest will experience a, drum roll please, solar eclipse. Now these happen all the time. They happen twice a year, every year. They have since the existence of the Earth, but most of the time the solar eclipse and the umbra and the penumbra shadows that occur happen over the ocean.
Right.
Or they happen on another continent. And so every 10 years or so, somewhere in North America, you get to experience one of these. So what's happening, of course, on the solar eclipse is the sun is radiating out some light. The moon gets between the earth and the sun. And because these light rays come in, they hit the moon. The moon is our blocker. Okay? And based on the positioning of the moon, etc., there are two different shadows that are formed. There's this really dark, this very tiny space on Earth, with actually it's as dark as night. That's, of course, the, which part of the shadow?
The umbra.
The umbra. And then there's this other part, much larger, which we will be in next May. And we'll be in the penumbra shadow. It'll get hazy out. Don't look. Do not look at the solar eclipse. You'll burn your retina. Probably go blind. But you can. There are ways with which you can view it with a welder's mask. Of course, the internet will have special filters on cameras so you can watch them on your computer. But this does apply to your everyday life. You've probably seen the more common lunar eclipse. What's going on in the lunar eclipse?
Well, the lunar eclipse is the fact that the Earth is actually casting a shadow.
Right. So these obviously you see at night, and the moon passes in, and the Earth's shadow blocks out the moon. And it doesn't matter where you're at, you get to see this one. Mm-hmm. So people are much more familiar with this. So the moon passes into the umbra created by the Sun-Earth system. So this happens. In your investigation today, you guys did something like this, didn't you? Where you worked on, you had a light source, and then you created a shadow puppet of some kind, and you broadcast the shadow onto a screen. Is that correct?
Yep.
So talk to me about that. What happened?
Well, what you're doing is you're kind of creating like that solar eclipse. I mean, you got the light shining on the puppet, where if it was the solar eclipse, the puppet becomes the actual moon, and your screen is like the Earth.
Okay. So what happens is this is just causing a blockage. And we were supposed to show that light travels in a straight line. So if we assume this is a point, because we are going to assume that it's not in a moment. If we assume this is a point, then the light extends, it hits our object, and we only create an umbra shadow. And so it gets to be very dark. Now there were conditions, right? We could move the object and change the object distance to the screen, and we could change the distance between the light source and the object as well. And we could create fuzzy or crisp shadows. Crisp meaning definable lines. So if I moved my object, let's say the object was close to the light, am I going to get a fuzzy or a crisp shadow?
You're going to get a fuzzy shadow.
Yeah, and if I get the object close to the screen, I'm going to get
Crisp.
And the biggest my shadow can get is big.
Right.
It's not really, I couldn't really define it. It's just big. But at some point, if I get too close to the light source, the shadow doesn't really seem to go away. It doesn't seem to appear. It seems to go away. The light seems to kind of move around it and just find the screen anyway. It's just a dimmer light.
It's like it's bending.
Yeah, kind of like this thing called diffraction.
Yeah, maybe.
Maybe. And then if I move the object really close, the shadow gets really crisp and clear. And how small does the shadow get?
Almost to where it's the same size.
Yeah, about the same size of the object. So there are limitations in the size of the shadow. What if this wasn't a point source? What if the light from the top of my light bulb hit the top of my object and the bottom of my object? And what if the light from the bottom of my light bulb hit the top of my object and the bottom of my object? What is this here? Is this still the umbra?
Yes.
Right, because there's no light getting there.
Correct.
But over here we're only getting partial light and partial light. So what's this called?
A penumbra.
This is called the penumbra. Right?
Mm-hmm. And one of these things, if you have a bathroom and if your back's to like lights on a mirror, especially if you have those track mirrors, if you look at a wall, you'll actually see like 8 different versions of your shadow.
Yeah, and that's exactly what you're seeing. So the different shades of gray, those are the penumbra shadows. Right? And then where it's totally blocked out, that's the umbra shadow. And then the last thing we should talk about is the angle. The angle matters. So I got my screen, and you guys took your puppet and you moved it. So maybe my light was stayed, relatively stationary for safety purposes. But if I moved my object up here, did the shadow still appear over here?
No, not really.
What would happen, of course, is the shadow would shift. And the shadow, if I drew a straight line between the shadow and the light source, the object would always fall in between it. If I moved my object down here, I would get the same basic effect. So this angle, which, by the way, causes long shadows during sunrise, sunset, short shadows at noon. Okay, angle shows us that light travels in a straight line. Light does bend, it does diffract. But if it truly diffracted, and I mean it really moved around, would we get a shadow?
No.
We couldn't, right? Because the light would fill in and the shadow wouldn't exist. It would just be a different place. I don't know how weird it would be, but it would be a different place. We wouldn't know the difference.
Well, there would be no shade in the summer.
There would be no shade. Yeah, okay, I would notice that. So it's just something to think about. Light doesn't really diffract around objects. When the object is really close to the light source, like right here, okay, what ends up happening most of the time, these objects aren't truly opaque, which means that they're allowing, the light is so intense that at this distance it's actually passing through the object. Right. And then it's getting to our screen. So, I think that covers it.
I think so.
That's shadows, so hopefully you heard something new today and you can apply it to your chapter challenge project. Lots of applications here. Signing off, this is Mr. White.
Mr. Johnson.